Far from the sun, under ice, in permanent night, there is water. All of it together is more than every ocean on earth. One moon of Jupiter, called Europa, may hold twice the water of our own oceans. The ice above that ocean is broken into plates like pack ice on a winter sea. It stays liquid without sunlight, warmed by the slow heat of rock and by the pull of the planet it circles. Over the next 2 hours we will go down through that ice together, slowly. There is nothing for you to do now. Close your eyes and let your breathing slow. For most of the years that people have wondered where else water might lie, they looked towards the sun. The reasoning was simple, and it felt sound. Water stays liquid only within a narrow band of temperature, and warmth came from sunlight, so the places worth checking were the places near enough to be warm. Venus, then Earth, then Mars. A thin, comfortable ring around one ordinary star, and beyond it the assumption of ice and nothing more. That assumption held for a very long time. It shaped which worlds were mapped and which were left as small, bright points at the edge of a telescope. The outer solar system was understood as a cold storeroom. Whatever water lay out there was surely frozen hard, locked into rock and dust, going nowhere for 4.5 billion years. The thinking was sound as far as it went. It was also wrong, and the shape of that error is the quiet subject of this film. Sunlight at Jupiter is about 25 times fainter than the light that falls on your garden. Farther out at Saturn, fainter still. Nothing about that has changed. What changed is the discovery that liquid water does not actually require the sun, only heat, and heat can come from underneath. It can come from the slow decay of elements inside a rocky core. On some of these worlds it comes from gravity itself, from the way a moon is pulled and released and pulled again as it goes round its planet. The moon flexes very slightly and warms from within, the way a wire warms when you bend it in your hand. And so the water turned out to be in the wrong place, or rather in the place nobody had thought to look. Not on the warm side, near the light. Out in the cold, under lids of ice, in permanent darkness, in quantities that make Earth's oceans look modest. Our own sea covers most of the planet, and by the standard of the outer solar system it is a shallow thing, about 4 kilometers deep on average. There are 5 worlds in this story, and they are all moons. The first is Europa, which goes round Jupiter once every 3.5 days. It is a little smaller than our own moon, and one of the most reflective bodies known, so bright it looks less like a rock than something newly made. The whole of it is ice, marked by long dark lines running in every direction, and under that lid almost certainly lies a global ocean of salt water. How thick the lid is, nobody yet knows. The second is Enceladus, which belongs to Saturn and is very small indeed, only about 500 kilometers across. You could set it down inside a mid-sized country and lose it. It is the whitest object in the solar system. From 4 warm fractures near its south pole, it throws water continuously into space, a fine mist of ice grains rising off a moon you could drive across in a long day. The third is Titan, the largest of Saturn's moons and the strangest of the 5. Titan has a thick orange atmosphere and weather and rain and rivers and seas near its north pole with shorelines and estuaries. None of it is water. At about -180 degrees, water on Titan is bedrock, and the liquid that falls and flows in pools there is methane. Whether Titan also holds a water ocean far below is a question that has recently reopened. The fourth is Ganymede, the largest moon anywhere in the solar system, larger even than the planet Mercury. It is thought to hold more water than all the water on Earth's surface, buried beneath perhaps 150 kilometers of ice, layered rather than simple. The fifth is Callisto, the outermost of the 4 large Jovian moons, old and dark and crowded with craters, a surface essentially unchanged for 4 billion years. Callisto may have an ocean too. The evidence is real but incomplete, and the truthful position is that we are not yet sure. It is the honest maybe of the group, and it belongs here for that. None of these oceans has ever been seen. That is worth settling into early, because it changes the tone of everything that follows. No camera has looked at them. No probe has touched them. Everything we believe about them has been inferred from the outside, from magnetic fields that behave oddly, from the tilt of a wobble, from cracks that resemble cracks in Greenland. We are reading the lid to guess at the room. And what we picture in that room is not a sea like ours. There is no wind above it, because there is no sky. There are no waves breaking on any beach, no light of any color at any depth, no day and no night. There is only water, still and cold and salted, held liquid by pressure and by whatever heat leaks up from below, pressing quietly against the underside of the ice for longer than there has been anything alive on Earth. So this is ice and water, the 2 substances you have known since you were a child, doing something unfamiliar a very long way from here. There is nothing frightening in it. It is simply dark and quiet and much older than we are, and it has been going on the whole time without needing anyone to watch. So let the room grow dim and let us begin where the heat comes from. A paperclip is the easiest place to begin. Take one and bend it back and forth in the same spot, 20 or 30 times, then hold the bend against your lip. The bend will be faintly warm to the touch. Nothing was burned and nothing was lit. You simply put work into the metal, and the metal handed a little of it back as heat. That is very nearly the whole of the physics that keeps water liquid at the cold edge of the solar system. The rest is only a matter of scale. Whole worlds bend in much the same way. Rock and ice are stiff, but stiff is not the same as rigid, and across the width of a moon even unyielding material gives a little. A large planet pulls harder on the near side of a moon than on the far side, and that difference in pull draws the whole body very slightly out of round. It becomes a gentle egg shape, with the long axis pointing at the planet. A bulge on its own, though, is not the point. A bulge on its own does nothing at all. If the orbit were a perfect circle, and the moon kept one face always turned toward the planet, that bulge would sit there fixed and quiet, generating no heat whatever. Hold the paperclip bent, and it never warms. The warmth comes only from the bending changing, over and over, in the same place. So the orbit has to be a little out of round, and this is where the outer moons become interesting. Europa's path around Jupiter is very nearly circular, but not quite. It draws a little closer, then a little further away, and the pull it feels rises and falls with a rhythm of roughly 3.5 days. Because its speed along that path changes while its rotation stays steady, the moon also rocks gently from side to side. The bulge grows, eases back, and travels slowly around the body. The numbers are smaller than you might expect, and somehow better for it. The ice at the point nearest Jupiter is thought to rise and fall by something like 30 meters once in every orbit, standing highest when Europa is closest to Jupiter and lowest when it swings furthest away. There is no wave in this, no roar, nothing you would see standing on the surface. It is a slow tide moving through solid material, and the friction of that motion spread through hundreds of kilometers of ice and rock adds up over billions of years. There is a difficulty sitting in the middle of this, and it is the reason the rest of the chapter exists. Tides that generate heat must take the energy from somewhere, and what they take it from is the orbit itself. Left alone, that steady drain would round the orbit out. Once the path became a true circle, the bending would stop, and any ocean beneath the ice would begin, very slowly, to close over. Europa should long ago have settled into quiet and cold. It has not, and the reason is that Europa is not alone out there. 3 of Jupiter's large moons are caught in a pattern so tidy it was worked out in the late 1700s, long before anyone knew what those moons were made of. In the time Io takes to go round 4 times, Europa goes round twice and Ganymede goes round once. So the 3 of them return to the same arrangement again and again, and each time they do, they give one another the same small gravitational tug at the same point in the journey. Nudges delivered at random would cancel each other out. Nudges delivered on the same beat endlessly do not. That repetition holds Europa's orbit very slightly out of round, by about 1 part in 100, and the flexing continues because its neighbors will not let it stop. The heat under Europa's ice is not really a gift from Jupiter. It is something the moons do to one another and have been doing for a very long time. Callisto, the outermost of the 4 large moons, sits outside that pattern with no partner to keep it stirred. Its orbit is calm, its interior is calm, and its ancient face is crowded with craters that nothing has ever smoothed away. The contrast with Europa is one of the plainest lessons in the whole system. How much heat all this produces is genuinely unsettled. Estimates for Europa cover a wide range, and researchers still disagree about how it divides between the ice above and the rock below. That uncertainty is not a failure of the science. It is what a question looks like before the right instrument has arrived. None of this makes these oceans warm in any way a human body would recognize. The water sits close to its freezing point, held liquid by salt and by pressure, and by a modest trickle of heat from beneath. What the flexing achieves is far quieter than that word suggests, and far more remarkable. It keeps water from freezing in the dark, at a distance where everything ought by rights to be stone. Not every ocean out there is held open this way. Further from the tidal engines, other moons may rely instead on the slow heat of decaying elements inside their rock. Salts and other compounds lower the temperature at which water hardens, and a thick lid of ice acts as a blanket over everything below. The mechanism varies from world to world, and some of it is still argued over. What holds across all of them is only this: whatever keeps the water liquid arrives from within, and never from above. Of every solid surface we have photographed in the outer solar system, Europa's is among the smoothest. There are ridges on it, and long, low swells and cracks, but almost nothing that rises or falls by more than a few hundred meters. Set it beside our own moon, which it very nearly matches in size, and the difference is immediate. The moon keeps every mark it has ever taken. Europa keeps almost none of them. Craters are the clock we use for a world we cannot visit. On an old surface they crowd and overlap, the newest sitting inside the worn rims of the oldest. On Europa you could almost name them one by one. From those counts, most estimates place the age of the visible surface somewhere between 40 and 90 million years. It is worth pausing on what that means. The counting itself is a measurement, and anyone can repeat it from the same images. The age that follows from the counting is an inference, and it rests on how often you believe things arrive to strike a moon out at Jupiter's distance. Change that assumption, and the number moves with it. What does not move is the direction of the answer. Europa has been remade, and on the evidence it is being remade still. What covers it instead of craters is lines. Long dark bands run across the ice in every direction, some of them thousands of kilometers from end to end, crossing and recrossing until the moon looks like a cracked shell held together by its own cracks. They are known to astronomers as lineae. Against the pale ice they read as brown or reddish or a dull orange, and that color is an open question. Pure water ice would not look like that. Something else is mixed in along them, most likely carried up from below and altered by long exposure, and the exact recipe is still argued over. The most common feature on the whole moon has a simple shape. Two parallel walls of ice, a few hundred meters high, with a narrow trough running between them like a country road with banks thrown up on either side. They are called double ridges, and there are thousands of them. In 2022, researchers studying radar and elevation data from northwest Greenland found a double ridge on the ice sheet there with the same shape, once you allow for the stronger gravity, as the ones on Europa. On Greenland, the cause is known. Meltwater works its way down into the ice, gathers in a shallow layer, freezes, expands, and forces the ground above to lift open in two parallel walls. Whether the same thing happens on Europa is not known, but it is the same form, and on Earth it is made by water inside ice, and that is a quiet hint. Then there are the broken places. In some regions, the ice looks as though it was shattered and then set again. Blocks of the older ridged terrain sit tilted, rotated, carried away from where they clearly began, embedded in a rougher matrix that seems to have flowed around them. Anyone who has stood on a frozen shore in spring will know the arrangement at once. It is what sea ice does when it breaks up, drifts a little, and freezes back together before the drifting is done. These regions are called chaos terrain. Connemara, the most photographed of them, stands slightly above the ground around it, while Thera, further south, sits below. One reading of that difference is that pockets of liquid water form and collapse inside the ice shell itself, only a few kilometers down, letting the lid above rise or founder. That reading came from re-examining old images and old measurements of height. Nobody has looked through the ice and seen a lens of it. Nothing there melts on its own. Averaged over the whole moon, the surface sits at around minus 180 degrees. At the equator at midday it may climb to nearer minus 140, and near the poles it falls to around minus 220. Those figures come from models rather than from thermometers laid on the ground, and they shift with what you assume about brightness and heat from within. At such temperatures, water ice is not a soft material at all. It behaves the way rock behaves at home, and it can hold a ridge up for a very long time. Underneath all of it lies the thing nobody can yet measure. Published estimates for the thickness of the ice run from about 3 kilometers to about 30, a difference of 10 times over, and 2 pages from the same space agency will give you different answers. The most recent attempt used microwave measurements from a single pass and returned about 29 kilometers, give or take 10. That applies only to the cold, rigid upper part of the shell, only to the ground actually observed on that pass, and only if the ice is pure water. Add salt, and the figure comes down. Put a warmer, slowly turning layer beneath it, and the total grows. The same work suggested something else worth carrying with you tonight. The top of the shell is not clear glass. It appears to be cracked and porous to depths of hundreds of meters, grained at the scale of a centimeter or less. A bright, cold, almost uncratered lid, stained with long lines, littered with refrozen rubble, lying over something we have never seen. How far down that something begins, nobody can yet say. The case for Europa's ocean was never made by seeing water. It was made by measuring a magnetic field and then asking patiently and for years what could possibly be producing it. Jupiter carries an enormous magnetic field, and the axis of that field is tilted away from the axis the planet turns on. So as Jupiter rotates, the field around it does not hold still where Europa happens to be. It rises and falls again over and over in time with the giant planet turning. Europa sits inside that slow rocking, and the useful question is what within the Moon answers to it. The Galileo spacecraft, which worked in the Jupiter system through the 1990s, carried a magnetometer, and it passed close enough to feel the field near the Moon. What it found was that the field there was not simply Jupiter's. A second, weaker field lay on top of it, arranged the way a field would be arranged if something inside Europa were generating one of its own. And it shifted as Jupiter's field shifted, always answering, always a little behind. That is very old physics, and you may have met it in a school laboratory. Move a magnet near a loop of wire, and a current begins to flow, and that current raises a magnetic field of its own, opposing the change that made it. Europa has no loop of wire in it. A globe-wrapping layer of salty liquid water would behave the same way, because dissolved salt lets water carry an electrical current, while cold ice, by comparison, barely conducts at all. Two analyses of the Galileo data, one published in 1998 and a stronger one at the turn of the century, concluded that a conducting liquid layer was the best explanation for what the magnetometer had recorded. That remains the single strongest line of evidence, and it is why the ocean is spoken of with confidence rather than hope. It is worth knowing what such a measurement cannot tell you. The induced field depends on how well the whole layer conducts, taken together, and that single quantity can be reached in more than one way. A thinner ocean that is very salty and a deeper ocean that is milder look much the same from outside. So the field tells you that a conducting liquid shell is there and leaves its depth and its saltiness trading against each other, both of them loosely held. The surface adds a second kind of argument, quieter and more circumstantial. A face as young as Europa's on a moon whose outer neighbor still wears every scar it has ever taken has to be getting remade from somewhere, and something soft and mobile must lie underneath to do the remaking. Two features carry most of the weight. The broken country described earlier carries some of the weight too, since pockets of liquid held inside the shell are the readiest way to explain ice that shatters and sets again. That reading came from old pictures looked at afresh, and it is an argument rather than a sighting. The other line of argument was walked through earlier when we looked at the ridges themselves. If those long paired walls are made the way their Greenland twins are made, then shallow water is not rare inside Europa's lid but common, threaded all through it. If Europa's ridges are made the same way, then shallow water is not rare there but common, threaded all through the lid. Then there are the models, which take every measurement there is and ask what interior would reproduce them. They are good and careful work. They are also arithmetic about a place nobody has visited, and their answers move when their assumptions move. Which brings us to the honest edge of all this. Nobody has ever seen Europa's ocean, sounded it, photographed it, or held a drop of it. Every line of evidence is indirect, and the indirect lines happen to agree. The one thing that might have carried the ocean up to us has stubbornly refused to settle. In 2012, Hubble recorded an ultraviolet glow above Europa's southern hemisphere that was read as water vapor rising high above the ice. Repeated attempts to see it again over several later years found nothing. Other candidate sightings at the moon's edge were later shown to be consistent with ordinary statistical noise, and a careful reanalysis concluded the original signal was most likely a fluke. One ground-based detection of vapor came on a single night out of 17. In 2023, the far more sensitive James Webb Telescope looked and saw no plume at all. So Europa may vent now and then, weakly. It is not Enceladus, and the two should never be spoken of in the same breath. For now the ocean remains a thing we have felt through a magnetic field and read in the shape of broken ice, and not yet a thing we have touched. Saturn keeps a small white moon that would fit inside a large country with room to spare at the edges. Enceladus is about 504 kilometers across, a modest thing beside the other icy moons. Europa is 6 times wider than that. You could drive the length of this moon in a single long day, if there were anywhere on it to drive to. It goes round Saturn in a little under 33 hours, at a distance of roughly 238,000 kilometers. A year there passes in less than a day and a half here. William Herschel found it on the 28th of August, 1789, as a faint point of light close in against the glare of the planet. For nearly 2 centuries after that, it stayed a point of light and nothing more, and nobody had reason to think it more than a frozen pebble. The first surprise about it is simply how bright it is. Enceladus reflects roughly 8 parts in every 10 of the sunlight that falls upon it, which makes it the most reflective body we know of anywhere in the solar system. Fresh snow on a winter morning barely matches it, and nothing else in the solar system comes close. Because it turns nearly all of that light away again, it keeps almost none of the warmth, and the average temperature of the surface lies somewhere near -200 degrees. It is bright for the same reason it is cold, and both of those facts turn out to have a single cause. Travel to the southern end of the moon and the ground changes. The cratered country gives way to a smoother region, and across that region run 4 long parallel fractures. They were named for the tales of the 1001 Nights, so the map there reads Alexandria, Cairo, Baghdad, and Damascus. Each one runs about 130 kilometers, roughly 2 kilometers wide and 500 meters deep, with low ridges about 100 meters high standing along either flank. What is strange is how evenly they are laid out. They sit about 35 kilometers apart, 4 near parallel scars, spaced the way furrows are spaced in a plowed field. Those 4 fractures are also warmer than everything around them. Along Damascus, the temperature climbs to at least -93 degrees, while the ground to either side of it lies far colder below -200. On a moon of this size, that is an enormous difference, and it is confined almost entirely to the fracture lines themselves. Warm scars on a frozen face. In 2005, the Cassini spacecraft worked out why. Its magnetometer picked up something bending the local field, Its cameras caught a haze above the southern limb, and its other instruments found water vapor where there ought to have been none. When the moon was photographed from behind, with the sun beyond it, the whole southern pole was seen to be venting. Fountains of water vapor and fine grains of ice were rising continuously from those four fractures out into the dark. For a while people spoke of geysers and counted them by the dozen. The picture that is held up better is a little different and rather lovelier. The fractures erupt along their whole length, more like curtains of vapor standing above a seam than like separate spouts. The brighter jets that were counted are often places where a curtain folds and you happen to be looking along its edge. What stands above the South Pole is not a row of chimneys. It is four long veils drawn up out of four long cracks. The material leaves at roughly 400 meters a second. That number matters because it takes only about 239 meters a second to escape this moon's gravity altogether. So a portion of everything that comes out never comes back. Around 200 kilograms of water leave Enceladus every second, and most of it falls again as the finest imaginable snow drifting down slowly onto a small world with almost no gravity to hurry it. That is why the surface is so white. The moon has been quietly snowing on itself for a very long time, and every fall lays down another clean layer. What does escape spreads out around Saturn as a broad, faint band of ice grains, the outermost and most diffuse of the rings, so thin and so wide that you could pass through it without ever noticing. One small moon breathes out, and a ring appears where the breath goes. The part that still seems improbable is that a spacecraft flew through it. Cassini did this more than once, and on the 28th of October 2015 it made its deepest pass. The craft dropped to about 49 kilometers above the south polar terrain and went straight through the rising plume. There was no landing and no drill, and no argument about reaching whatever lies below the ice. The moon was lifting its own water up into space, and a machine simply drove through the middle of it with its instruments open. The venting has not stopped since. In 2022, the James Webb Space Telescope looked at Enceladus and traced the water vapor out to about 10,000 kilometers. That is some 40 times the moon's own radius, a long, soft tail of it feeding a great donut of vapor circling Saturn. The rate matched what Cassini had measured 15 years before. Whatever is happening down there has been steady for at least that long. The water it flew through carried more than water, and that is the next quiet thing to go through. The instrument that did most of this work was a mass spectrometer, and the idea behind one is plainer than its name. Something enters at speed, breaks into fragments, and the fragments are sorted by how heavy they are. What comes out is a list of masses, and from that list you can read a recipe. Tasting is a fair word for it. The spacecraft never saw the ocean of that small moon. It flew through a thin veil of what the ocean had thrown upward, and it read the veil. Water came first, and water dominated. Between 96 and 99 parts in 100 of the gas was water vapor. carbon dioxide made up under 1 part in 100, methane rather less, ammonia a little more. These are small numbers, and small numbers are exactly what you want because they are the trace of something rather than the whole of it. Then there was the salt itself. The ice grains carried sodium chloride, which is the ordinary salt of a kitchen table and of the sea. The measured amount is lower than in Earth's oceans, perhaps a third of it, perhaps a sixth, and it came mixed with carbonates, so the water is alkaline rather than neutral. If you could bring a spoonful of it to your mouth, it would taste faintly of salt and rather more of soda. That single fact does a great deal of work. Ice melted from a clean frozen surface would come back almost pure. Water that has been sitting against rock, dissolving it slowly, comes back salted. The spray is not melted snow but water from a sea. The dust analyzer found something smaller still. Scattered through the faint outer ring were grains rich in silicon, only 2 to 8 nanometers in radius, and they traced back to the same moon. Grains of that composition and that narrow a size range form in one known way, in water hotter than about 90 degrees reacting with rock, and they must be carried upward quickly afterwards or they would grow. So the most plausible reading is that somewhere at the bottom of that ocean, tens of kilometers down, hot water is meeting stone. Nobody has seen a vent there, and nothing has been photographed or touched. What exists is the chemistry that hot water meeting rock leaves behind, which is a weaker claim and an honest one. The deep pass came in October of 2015, 49 kilometers above the southern ice. Among the gas, the spectrometer found molecular hydrogen, somewhere between 4 and 14 parts in 1,000. Hydrogen is light, and it escapes easily, so a store of it does not sit around for ages. The most plausible reading is that it is being made now continuously by water reacting with reduced rock below. Here is where care matters. Hydrogen together with carbon dioxide is a chemical energy source. On Earth, certain microbes live on that pairing and nothing else. What the measurement establishes is that the energy is available, that the ocean is out of chemical balance, and that something could in principle draw on it. It establishes nothing whatever about whether anything does. The teams who published it said as much themselves. The organic molecules ask for the same restraint. Analysis of the ice grains turned up large carbon-bearing fragments, some heavier than 200 atomic mass units, built of carbon rings linked to chains, with nitrogen and oxygen attached at various points. Later work on fresher grains, caught before space could weather them, added smaller and more familiar molecules, the kind of carbon rings and light compounds that warm water and rock will make between them given enough time. The authors of that work described them as the ordinary products of warm water, rock, and time. The plain fact behind all of it is easily missed. Carbon chemistry builds itself readily without any help from biology. Meteorites that have never been near a living thing arrive carrying dozens of amino acids, and the mixture of their mirror forms is very nearly even, which is precisely the fingerprint of chemistry rather than life. Finding organic molecules somewhere is not a hint. It is the expected result. In 2023, phosphorus was added to the list in the form of sodium phosphates read out of 9 ice grains. Phosphorus assembles the backbone of genetic material and the currency of cellular energy on Earth, and it had been the last of the 6 common elements of life not yet found in that ocean. The inferred concentration is at least 100 times what dissolves in Earth's seas. That is a striking measurement, and it remains a measurement of a mineral. The word the field uses for all of this is habitable, and its meaning is narrower than it sounds. Habitable describes the capacity of a place to support life, not the presence of any. A room can be entirely livable and entirely empty. That is the accurate description of what has been read from the spray so far. Water, salt, warmth at depth, carbon chemistry, phosphorus, and an energy source gathered in one place where all of them meet. There is one last thing worth saying, and it is the simplest. Everything read out of that spray was read from grains no wider than smoke, caught at speed by a machine passing through. A whole ocean was described from the little of itself it threw away. Titan is the one moon here that would look at first glance almost ordinary. It has a sky above it, and weather inside that sky, and rain that gathers into rivers and runs downhill to the sea. Its horizon is softened by haze, the way a long summer afternoon is softened here. Then you learn what the rain is made of, and the whole picture turns quietly over. Titan is the second largest moon in the solar system, a little over 5,100 kilometers across. That makes it about 6% wider than the planet Mercury, though far lighter because roughly half of Titan is water ice rather than rock and metal. It takes almost 16 days to travel once around Saturn, at a distance of about 1.2 million kilometers, always keeping the same face turned inward. What sets it apart from every other moon we know of is the air. Titan is wrapped in a real atmosphere heavy enough to press on the ground at about 1.5 times the pressure you feel at sea level on Earth. That is roughly what you would feel standing in 5 meters of water in a swimming pool, a gentle weight rather than a crushing one. Near the ground, the air is about 94% nitrogen, with methane making up most of the remainder. Our own air is mostly nitrogen too. Titan is the only other world we know of that is draped in the same quiet gas. The atmosphere reaches high, close to 600 kilometers above the ground, something like 10 times the depth of ours. Sunlight out there is faint to begin with, and much of it never reaches the ground. Between about 100 and 200 kilometers up lies a layer of photochemical haze built by sunlight out of nitrogen and methane into heavier molecules. The haze is orange, and it is everywhere. Daylight on Titan is a dim amber glow with no sun visible anywhere in it, more like the light inside a tent than the light of an open field. The ground beneath all of this sits at about 94 degrees above absolute zero, which is close to minus 180 degrees Celsius. Nothing on Earth is ever that cold, not even the poles in deep winter. At that temperature, water is not a liquid there and cannot become one, so it takes the role of rock instead. The hills of Titan, the cliffs, the stones lying in its valleys, are water ice with something like the hardness of granite. They behave exactly as bedrock behaves. They fracture and weather, and they are carried downhill and worn round, which leaves the work of water to be done by something else. Methane is the substance that takes the part. We know it as a gas, the one that burns blue on a kitchen ring, and hardly ever as anything else. But at Titan's temperature and pressure, methane sits close to the point where it can be vapor, liquid, and solid all at once, which is exactly the comfortable position water occupies on Earth. So methane does the work there that water does at home. It rises from the seas as vapor, it gathers into cloud, and in time it falls again as rain. Cassini watched those clouds come and go for years. During northern spring, it saw storms wet the ground near the equator, leaving dark patches that spread across the terrain and then slowly faded as the liquid drained away or lifted again. Nobody has ever caught the rain itself in the act of falling. What we have instead is everything the rain leaves behind. Radar-mapped branching networks of channels, valleys cut down into bright highlands, tributaries joining and widening, running for hundreds of kilometers and then arriving at a coastline. And at the end of those channels, the seas. They cluster around the northern pole, Kraken Mare, the largest, then Ligeia Mare, then Punga Mare with one major lake, Ontario Lacus away in the south. The names are borrowed from our own old stories of the sea. Around 400 lakes and seas have been catalogued, covering more than 1.5 million square kilometers, close to 2% of the surface, with most of that area held in the three great northern seas. Their liquid is methane and ethane with nitrogen dissolved in it, clear and cold and thin, and it is mostly very calm because Titan's winds are gentle and the heavy air rests on the surface. Radar sounding gave up some of their depths. Most of the measured lakes and seas fall between 20 and 200 meters, and Ligeia Mare returned echoes from as deep as 160 meters along one long track. In the middle of Kraken Mare, the radar looked down and never found the bottom at all. There is one more thing to hold in mind about all this weather, and it is unresolved. Sunlight slowly and permanently destroys methane in Titan's air, taking it apart and building it into heavier compounds that drift down and stay down. On that reckoning, the atmosphere should have run out of methane within a few tens of millions of years, which by the standards of moons is almost no time. Something must be putting it back. It could be methane released from ice deep inside, or methane made by reactions between water and rock far below. Nobody yet knows which it is. The rain goes on falling, and where it comes from remains an open question. On the 14th of January 2005, a small machine built on Earth came down through an orange sky and settled on ground that nobody had ever touched. It had crossed the distance riding on the side of the larger spacecraft that carried it and was released near the end to make the last of the journey alone. It met the top of the atmosphere at great speed, and the thick air slowed it, and then the parachutes opened above it and the falling turned gentle. The descent lasted about 2 hours and 27 minutes. That is worth resting on for a moment. Most arrivals at other worlds are a matter of minutes, a brief, bright commotion over almost before it begins. This one was long and unhurried, a drift of 2.5 hours down through layer after layer of haze, with the probe turning slowly beneath its canopy and looking around as it went. For much of that time there was very little to see. The haze on Titan is deep and high, and from the inside it is a warm, featureless glow, the color of weak tea held up to a lamp. Then, lower down, the murk began to thin and the ground came up out of it. What the camera found was a landscape anyone from Earth would read at a glance. There were highlands, paler than the rest, and cut into them were branching networks of valleys with dark floors, narrowing as they climbed, joining as they descended, exactly the pattern that running liquid carves into a slope. The valleys ran down to the edge of a broad, dark plain, and the boundary between the bright ground and the dark ground looked, in those first frames, like nothing so much as a coastline seen from a small aircraft. It is a strange thing to travel that far and arrive somewhere so legible. The probe came down not on the bright uplands, but out on the flat, and it landed softly. Its speed at the moment of contact was about 4.5 meters per second, which is roughly what you reach if you step off a kitchen table. There was no tumble and no long skid. It touched, pressed a little way in, bounced once, slid perhaps a hand's breadth across the ground, and rocked gently back and forth for a few seconds before it came to rest. A small instrument on the underside pushed into the ground as it arrived, and recorded what the surface was like to a depth of about 10 centimeters. The ground gave way easily. The reading corresponds to something softer than dry rock, and softer than hard ice, closer to wet sand near the tide line, or to snow that has been lightly packed underfoot. Something harder was met first and then gave way, most likely a single pebble just beneath the top layer. The pictures taken after landing show why. The ground is covered in rounded cobbles and pebbles, most of them roughly 5 to 15 centimeters across, lying on a darker, finer material like grit. None of them have sharp edges. They have the shape that stones acquire only from being rolled and carried and knocked together by moving liquid over a long time, which is the same shape they take in any riverbed on Earth. On Titan, they are made of water ice, hard as rock at that temperature, and the liquid that rounded them was methane. Then came the detail that turned the picture into a place. The warmth of the probe resting on the ground was enough to raise a little methane out of the soil beneath it, and the instrument sampling the air registered the rise. The ground beneath it was damp. Not flooded, not a lake, not a shore with liquid lapping at it, but soil holding methane the way beach sand holds water some distance up from the sea. There was also an attempt to listen. The probe carried an acoustic sensor, and it worked, and the recording that has been shared with the public since is not quite a field recording of wind. Part of it is a reconstruction assembled in a laboratory from what the sensor measured at different moments. The rest of it is the radar sounding of the last few kilometers, turned into rising tone and volume as the ground came nearer. So it is fair to say an instrument listened, and that what came back was made into something a human ear could follow. That is a smaller claim than the one often made, and it is still remarkable. After landing, the probe simply kept working. It went on transmitting from the surface for 72 minutes, sending back what it could see and taste and feel of a floodplain more than 1 billion kilometers from the workshops where it was built. It stopped, not because it failed, but because the spacecraft relaying its voice slipped below the horizon of that landing site and could no longer hear it. Radio dishes on Earth followed the bare carrier tone a little longer. The batteries are thought to have run down about 15 minutes after the last of it was heard. It is still the most distant landing ever made, and the only landing anywhere in the outer solar system. It remains exactly where it came to rest, on a dark plain scattered with rounded ice pebbles, under a sky the color of a lit lampshade, with no one due to visit for a very long time. Nothing about it was loud. A few hundred people watched some numbers arrive, and the numbers meant that a small thing from here was lying quietly on the ground somewhere else. Below the methane, and below the damp dark ground where the probe came to rest, there may be water. Titan is roughly half water ice, with rock only deep inside it, and for about 2 decades the models have placed a global layer of liquid water 50 to 100 kilometers down. That water would not be pure. It is thought to be salty, and it may carry a good deal of ammonia. Ammonia lowers the temperature at which water freezes, and it lets a liquid persist where it would otherwise be far too cold. That gives Titan an unusual and rather lovely shape. There would be liquid on top, in the lakes and the wide northern seas, made of methane and ethane. There would be liquid far below, made of water. Between the two would sit a shell of ice thick enough that they can never meet. Each would be a sea by its own chemistry, and neither could ever reach the other. Nothing else we know of is built quite like that. The reasons for believing in the deeper sea arrived from 3 directions, and not one of them involved seeing it. The probe carried instruments sensitive to the electrical behavior of the air around it, and what they recorded during the descent was easiest to explain if a conducting layer lay beneath the crust. The tilt of Titan's spin was a second clue, because it behaved in a way that a single rigid body should not. The third came from gravity. Cassini flew past many times, and the pull it felt changed slightly as Titan moved around its orbit by more than a solid interior would allow. Something in there was flexing. Then, late in 2025, that picture was challenged. A team went back to the old radio tracking data with better methods and measured for the first time the delay in how Titan responds to Saturn's pull. The delay implies that a great deal of energy is being lost inside the moon as heat, and a global ocean, being fluid, would cushion the whole interior and suppress exactly that loss. In place of an ocean, they propose a thick layer of high-pressure ice, sitting close to its melting point, soft and slushy rather than liquid, holding scattered pockets of meltwater within it. Other researchers have formally disputed the reading. A reply has been published in turn, and still other work argues that a Titan without an ocean would be unstable and would simply grow one again. So the honest position is that a question which felt settled for 20 years has opened once more. Further in towards Jupiter, the ground is steadier. Ganymede is the largest moon in the solar system, wider even than the planet Mercury. Beneath a crust of ice, perhaps 150 kilometers thick, there is thought to lie an ocean of salt water, around 100 kilometers deep. By NASA's own careful wording, it may hold more water than all the water on Earth's surface. Its warmth is not the tidal warmth of Europa. Ganymede is kept liquid mainly by the slow heat of decaying elements in its rock, by salts and ammonia that lower the freezing point, and by the insulating blanket of ice lying over everything. Ganymede has one further distinction. It is the only moon known to generate a magnetic field of its own, found by the Galileo spacecraft in 1996, and most likely stirred by molten metal moving in its core. That field draws glowing ovals of aurora around the moon's high latitudes. Because Ganymede sits inside Jupiter's far larger field, those ovals should rock back and forth as Jupiter turns. Hubble watched them, and they rocked far less than they ought to have done. A layer of conducting salt water under the ice would damp the motion by very nearly that amount, which is the best evidence we have for an ocean there. Deep inside Ganymede, water stops behaving the way you know it. Ice floats everywhere in ordinary life, and that is the famous oddity of the substance. Under enough pressure, though, the crystal packs into a tighter arrangement, becomes denser than the water it formed from, and settles instead of rising. Models of the interior therefore stack layers of ocean and ice one upon another, like a sandwich, with the deepest ice pressed hard against the rock. Whether any liquid water actually touches that rock is not known. Add enough salt to the models and the lowest water becomes heavy enough to sink through, but that remains a calculation rather than a finding. Callisto is the quiet one, farthest out of the 4 large moons, carrying the oldest and most heavily cratered face in the solar system. It never joined the rhythm that keeps the inner 3 flexing, so it has almost no tidal heating, and by rights it ought to be frozen through. Yet Galileo found a magnetic disturbance around Callisto too, of the kind a buried conducting layer would produce. The difficulty is that Callisto's thin upper atmosphere also conducts, and it can imitate the same signal. Newer work, comparing the response across several frequencies, finds that the atmosphere alone cannot account for everything observed, while an ocean together with an atmosphere fits well. That is stronger evidence, and it is not proof. Somewhere below 150 kilometers of ice, and possibly a good deal deeper, Callisto may be holding water that nobody has yet confirmed. 3 moons, then, and 3 different kinds of knowing. Titan is being argued over again, Ganymede is strongly implied, and Callisto remains a growing suspicion that has never quite arrived. Somewhere behind all of this, there is a simpler question, and it is worth asking slowly. How much liquid water is there in the solar system, and where is nearly all of it kept? Begin with the water you already know, because it is the measuring stick for everything else. Earth's oceans hold something close to 1.4 billion cubic kilometers of liquid water. Their average depth is about 4 kilometers, which sounds enormous until you set it against the size of the planet. Spread evenly over the whole globe, all of that water would lie only a couple of kilometers thick. Our ocean is wide rather than deep, a thin, bright film draped over a ball of rock. Now set Europa beside it, and the comparison stops being comfortable. The figure NASA gives for Europa's ocean is around 3 billion cubic kilometers, which the agency describes as more than twice the volume of all Earth's oceans combined. That water is held by a moon smaller than our own, about 90% the size of the moon in your window. Its average depth is thought to be near 100 kilometers against Earth's 4. One moon of Jupiter, smaller than the one you have watched all your life, may carry twice the sea. Ganymede is larger again, and the estimates made for it are larger still, though they rest on the same assumed depths as all the others. Two figures now in circulation for that one ocean differ by a factor of 3, which tells you more about the method than about the moon. Enceladus, by contrast, is close to a rounding error in this ledger. Its ocean amounts to something on the order of 1 or 2% of Earth's oceans, and no more than that. Its importance to us was never its volume. Callisto may hold an ocean and may not, and the case for it is still being argued in the journals. Titan's deep water, long inferred and lately questioned, is an entry written in pencil. None of those volumes, though, has actually been measured. Not one of those volumes has been measured. Every one of them is calculated from an assumed depth, and the depths come from models rather than from soundings. Europa is the clearest example of the problem. Nobody yet knows how thick its lid of ice is, and published estimates run from about 3 kilometers to more than 30. The magnetic reading, as we saw, cannot separate how deep that hidden layer is from how salty it is. So a depth has to be assumed before any volume can be written down. So a depth is chosen, and the volume simply follows from the choice. You can watch the consequences in the published totals, which do not agree with one another. Two circulating figures for Ganymede's ocean alone differ by a factor of 3. Grand totals for the whole outer solar system differ by more than that, and none of them rests on firm ground. This is why you will not hear a single tidy multiplier from me tonight. The number would be neater than the truth, and the truth is the more interesting of the two. What survives all of that uncertainty is the direction of the answer. Take the most cautious version of every estimate, throw away the generous ones, and the conclusion barely moves at all. There is more liquid water out among the icy moons than there is here, and probably a great deal more. Europa on its own, in NASA's own conservative phrasing, carries more than twice our seas, Add any of the others to that, and the balance tips further in a direction from which it does not come back. Then there is the second half of the result, which is the quieter half. Almost none of that water has ever been touched by light. Earth's ocean is lit only at the top, where sunlight reaches a couple of 100 meters down before it fades away. Everything beneath that is dark, and the dark part is already almost all of our own sea. Out there, the proportion is not almost all of it. It is the whole of it. No part of Europa's ocean has ever been lit, nor Ganymedes, nor the water under the south pole of Enceladus. That turns the usual picture gently inside out. Liquid water, taken as a whole, is not mainly a sunlit thing. It is a dark thing held under ice, kept liquid by warmth from below rather than from above. The bright blue version, the one with weather over it and a horizon and boats upon it, may well be the rarity. We grew up beside the unusual one and quietly assumed it was the rule. There is no need to make any of this feel large or unsettling. It is simply an inventory, and inventories are calming things to read. Somewhere out past the asteroids, in the dark, under lids of ice measured in tens of kilometers, there is more water than in every ocean, lake, river, and cloud on this planet. It has been there for billions of years, unlit, unhurried, and unwitnessed. It was there while every ship was built and every map was drawn. And it will still be there in the morning, exactly as it is now, doing nothing at all in the dark. There is a version of this whole story that you can reach by aeroplane. It lies at the bottom of our own world, beneath the Antarctic ice sheet, and it has been there a very long time. The ice there is kilometers thick. Underneath it, at the base, the ground is not frozen everywhere. Heat seeps slowly upward out of the rock below, and the enormous weight of the ice lowers the temperature at which water can hold its solid form. And so liquid water gathers down there. Many lakes have now been mapped beneath that ice, linked in places by streams and by thin films of water at the bed, a whole drainage network running in the dark under a continent of white. For decades, this was known only from radar. An aircraft flies a line, sends a pulse down through the ice, and listens for what returns. Rock gives one kind of echo, and a flat body of water gives another, unmistakably bright and level. That is how the largest of them was found under the Russian station named Vostok, below roughly 4 kilometers of ice in East Antarctica. A lake, and a very large one, with a mountain range of ice lying on top of it, sealed away from the sky for a length of time we can only estimate. Vostok is also the cautionary tale, and it is worth telling first because it teaches the habit of mind that the rest of this needs. Getting down 4 kilometers takes years, and the hole must be kept from closing under pressure. The Russian team held theirs open with kerosene and with a refrigerant fluid. That fluid arrived in tanks used for other purposes, and it was never sterilized. When the drill finally met the water in 2012, lake water surged up the borehole and mixed with all of it. The genetic sequences later recovered from the deepest ice were dominated by bacteria that feed on petroleum compounds, together with organisms associated with people and with garden soil. There were tantalizing exceptions, including a heat-loving bacterium otherwise known from hot springs in Japan, and one sequence unlike anything in the catalogs. But the honest summary is uncomfortable and useful. We reached the deepest of these lakes, and we still cannot say with confidence what lives in it. The lakes that answered were smaller and shallower, and they were approached with far more care. In January of 2013, an American project drilled into Lake Whillans in West Antarctica under about 800 meters of ice. They melted their way down with hot water rather than fluid and treated that water as the main hazard. It was filtered twice, down to a fraction of a micron, passed under ultraviolet light at 2 different wavelengths, and heated almost to boiling. The drill water was then sequenced on its own, so that whatever came up from the lake could be compared against whatever the drill had carried down. What came up was alive. Something like 100,000 cells in every milliliter, which is not a wisp of survivors but a working community, and something in the region of 4,000 distinct kinds of microbe. Crucially, that community did not match the drill water. It was its own thing entirely, and it makes its living from chemistry rather than light, drawing energy by oxidizing iron, sulfur, and nitrogen compounds released from the rock ground fine beneath the moving ice. No sunlight reaches that place, and none of the organisms in that water require any. A second lake was opened 5 years later, in the closing days of 2018, under about a kilometer of ice. Mercer gave up living microbes of the same general sort, making the same kind of living. It also gave up something nobody had asked for. In the sediment on its floor lay the remains of animals, tardigrades and small crustaceans, most of them well under a millimeter across. The lead scientist assumed at first that they were contamination. Fresh cores brought up more shells. They were remains rather than residents, most likely carried there long ago from a time when the region lay open to the air or to the sea. That distinction matters and should not be softened. Nothing living and larger than a microbe has been found in a lake beneath the Antarctic ice. So what does a lake under Antarctic ice actually tell you about a moon of Jupiter? Less than the headlines suggest, and rather more than you might think. It does not tell you that Europa is inhabited. Whillans sits on ground fed by meltwater and by rock flour in a system connected, however slowly, to the ocean at the ice edge. Europa's water has no such shore. What the Antarctic lakes establish is narrower and firmer than that. Permanent darkness, liquid water, and freshly exposed rock together make a combination that at least one world has found workable. Energy does not have to arrive from above. The second lesson is about method, and it may be the more valuable one. Almost all of the effort at Whillans and at Mercer went into knowing what the researchers had brought down with them. Filters, ultraviolet light, heat, and control samples of their own drill water, so that any finding could be tested against the dull explanation first. That is the standard now, and it is a high one. Anything we ever say about water under the ice of another world will have to be earned in the same slow way, and the ice at the bottom of our own world is where we are learning how. For most of the history of biology, one rule looked unbreakable. Everything alive on this planet ran, in the end, on sunlight. Green things caught the light and built sugar out of air and water, and everything else ate the green things. Follow any meal backwards far enough, and you arrive at a leaf, and behind the leaf a star. The deep sea seemed to obey that rule as faithfully as a meadow. The dark water kilometers down was understood as a place living on crumbs, on the slow fall of dead material drifting from the lit layers above. Nothing was expected to flourish there, and nothing was expected to be crowded. The dive that broke the rule was not looking for life. In February of 1977, a small submersible called Alvin went down onto the Galapagos Rift to a depth of around 2,500 meters, carrying geologists. Fresh seafloor is made along ridges like that one, and heat ought to be leaking out of the young rock. They found their warm water, shimmering where it met the cold. Standing in the shimmer was a city, clams as broad as dinner plates, mussels heaped on one another, pale crabs picking their way over the stone. No light of any kind reached that place, and yet more life was packed into a square meter of it than into most of the ocean above. 2 years later, on a different stretch of ridge in the eastern Pacific, the same little submersible found the fiercer version of the same idea. Chimneys of mineral, built by the fluid rising up through them, venting water measured at around 350 degrees. It stayed liquid because the pressure at that depth will not let it boil, and it stained the water dark as minerals dropped out into the cold. Black smokers, people began to call them. The answer to how any of it was possible lay in the water itself. Seawater sinks into cracks in the young rock, is heated, and comes back up loaded with the chemicals that hot rock and water make between them. Hydrogen sulfide is the principal one. There is methane in the mixture too, and plain hydrogen. Each of those holds chemical energy in a form that bacteria learned to open long ago. The bacteria draw that energy out and use it to build their own bodies from carbon dioxide dissolved in the sea. It is exactly the work a leaf does, except that the energy comes from the rock rather than the sky. Chemosynthesis is the name given to it. Every animal at a vent is living by one root or another on the back of that. The strangest of them makes the point better than any diagram could. The giant tube worm of the Pacific vents has no mouth and no gut. Inside its body, it keeps an organ packed with bacteria, and it provides for them rather than for itself. The scarlet plume at the top of the tube, the part that looks like a flower opening, is thick with hemoglobin. It gathers sulfide and oxygen and carbon dioxide out of the water and carries all three down through the animal's blood to the bacteria waiting within. The worm is a house and a delivery service and a garden, all in the one body. One correction belongs here because it is usually left out. Those communities are independent of sunlight as a source of energy. They are not independent of the sun altogether. The oxygen the animals breathe was made by photosynthesis at the surface and carried down in the sinking water. The energy is theirs, and the air is still borrowed. What that discovery did across the decades that followed was alter what counted as a reasonable thing to say aloud. Before 1977, a living community sealed under kilometers of ice, with no light ever reaching it, was a daydream with nothing behind it. Afterwards, it became a hypothesis, which is a smaller and more honest thing. It rests on a plain fact. The essential trick has already been performed once on this planet, in the dark at depth with rock and water as the only ingredients. So the caution has to be spoken plainly. Nothing living has yet been found anywhere beyond this world, and that is simply where the searching has got to. Europa's seafloor has never been seen, and whether hot water is meeting rock down there is genuinely argued over. Some researchers hold that the moon cannot generate enough stress to fracture its rocky floor or drive melt up through it, leaving the ocean quiet and chemically thin. Others point out that Europa's orbit has shifted over its long history, and that warmer chapters with more activity below remain entirely plausible. Neither side is being unreasonable, and the answer is not in yet. The word for all of this was given earlier, and it holds here without changing. A place can be entirely livable and still be nobody's home. The vents are simply the reason the question is worth asking. Before them, water under ice was only water under ice. After them, it became a room with the lights off and no way to tell from out here whether the room is furnished. That is a comfortable enough place to leave the matter tonight. Somewhere beneath the Pacific at this moment in water no sunlight has ever reached, clams are filtering and worms are standing in the warm flow, taking not one scrap of their energy from the sun. There is a set of rules for going to places that might hold water, and they are older and more carefully written than most people realize. They have a rather dry name. Planetary protection sounds like something handled in an office, on a form by someone with a stamp. In practice, it is closer to the etiquette of a guest, and it is one of the gentlest things our species has ever agreed to do. The agreement runs through an international committee, and it sorts destinations by how much harm a careless arrival could do. A dry, airless rock ranks low. A world thought to hold liquid water ranks high, and these icy moons sit near the top of that list along with Mars. For those places, the rule is written as a number. Any mission must keep the chance of accidentally introducing terrestrial life into that water below 1 in 10,000. The limit holds across every phase of the journey, and for as long afterwards as any stowaway could stay alive and find its way down to the liquid. The definition of failure is startlingly small. Contamination means one living microbe from Earth reaching an ocean that is not ours. Meeting that standard is patient, unglamorous work. Hardware is assembled in filtered rooms by people in full coverings, and parts are baked, wiped, and sampled. The cleanliness is not described in adjectives, but in counts. Some Europa clipper hardware was held to no more than 300 bacterial spores for every square meter of its outer skin, with a slightly looser figure allowed on certain components. The whole allowance was argued out beforehand in a long risk assessment rather than simply guessed at. Somebody, somewhere, sat down and worked out how much life a machine could carry and the journey still be honestly clean. It is worth being clear which way the care points. This is not about protecting Earth from anything out there. It is about protecting out there from us. Our microbes are extraordinarily good at traveling and at waiting, and a single one delivered into a dark ocean would ruin two things at once. It would alter a world that has been running its own chemistry without interruption for billions of years, and it would spoil the answer to the only question worth asking about it. If you ever did find something living in an ocean under ice, you would need to be certain it was not simply the descendants of something you brought with you. Which brings us to the two spacecraft that were deliberately set down into a planet at the end of long and healthy working lives. Galileo spent 8 years working in the Jupiter system, and among the things it found was the magnetic evidence that made people believe in an ocean under Europa's ice at all. By the end, its fuel was nearly gone. Without fuel, a spacecraft cannot be steered, and a path that cannot be corrected is a path nobody can make promises about. Over years and decades, and Jupiter's gravity being what it is, an uncontrolled Galileo might eventually have come down somewhere unfortunate. So on September 21, 2003, still working and still reporting, it was aimed into Jupiter's atmosphere and allowed to burn away in a place with no ice and no ocean. It was ended to protect a discovery it had made itself. Cassini went the same way 14 years later. It had been built and launched in the late 1990s, before anyone knew that a small bright moon of Saturn was quietly venting ocean water into space. So it had never been prepared to the standard you would want for a machine that might one day come to rest in such a place. When its own fuel began to run low, the plan was already written. It flew 22 final orbits through the narrow gap between the planet's cloud tops and the inner edge of the rings, gathering measurements nobody had been able to gather before. Then, on the 15th of September 2017, it turned into the atmosphere below it. The reason given named both of the moons it had been sent to study. Enceladus and Titan were to be left alone. Neither ending was a failure, and it would be wrong to hear them that way. Both spacecraft were healthy and working well. Both were doing science on the last day. The decision in each case was made calmly, years in advance, by people who understood perfectly well what they were choosing. They chose it anyway on the grounds that a place with water in it should be left as it was found. There is no crash in this story and no accident. There is only a long, deliberate act of tidying up. You know the feeling yourself, though at a much smaller scale. It is the instinct that makes you close a gate behind you on a walk through a field, or carry a wrapper home in your pocket because the hillside was clean when you arrived. Nobody at all is watching. No rule anywhere enforces it. You do it because the place was fine before you came, and you would like it to be fine after you go. The ocean under Europa's ice has no idea that any of this happened. Enceladus goes on, throwing its water into the dark exactly as it did before either machine arrived, and exactly as it will long after the last trace of both is gone. But the rule was kept. 2 working spacecraft were laid down carefully in the right place, so that a body of water nobody has ever seen could go on being entirely itself. 3 spacecraft are bound up in this question now, and not one of them is in any hurry. The first left the ground on the 14th of October 2024 from a pad in Florida, carried up by a rocket called Falcon Heavy. Its name is Europa Clipper. It will not arrive until 2030, and even then it will not stop at Europa. It goes into orbit around Jupiter instead, and from there it leans in toward the Moon and out again 49 times over. That looping design is deliberate. The radiation around Jupiter is fiercest close in, and a craft parked permanently above Europa would be worn down by it. So the mission is built around dodging. It comes as near as 25 kilometers above the ice, gathers what it can, and then swings back out into calmer space. The most delicate electronics ride inside a metal vault with walls about a centimeter thick. What it carries is a list of quiet, specific questions. A radar called Reason will look down through the ice at 2 frequencies at once, 9 MHz and 60, in what the engineers describe as a kind of medical scan of the shell. That is the instrument built to answer the thing nobody can yet answer, which is simply how deep the lid goes. A magnetometer will listen to the Moon's response to Jupiter's shifting field, and from that response, teased out over many passes, the depth and saltiness of the ocean may finally be pinned down. Other instruments will taste the thin gas above the surface, catch grains thrown up from the ground, map the warmer places, and photograph the terrain more closely than anyone has yet managed. NASA is careful about what this adds up to. Europa Clipper is not a life detection mission. It was sent to find out whether the place could support life, which is a smaller and more answerable question. The second machine left earlier and will arrive later. Europe's Jupiter Icy Moons Explorer rose from Kourou in French Guiana on the 14th of April 2023 and has been looping back past the Moon, the Earth and Venus, borrowing a little speed from each. It reaches Jupiter in July of 2031. Its attention is turned mostly elsewhere than Europa. Of the 35 closed passes it plans, 21 are at Callisto and only 2 at Europa, because its real destination is Ganymede. In December of 2034, if all goes as intended, it slows and settles into orbit around that moon and becomes the first spacecraft ever to circle a moon other than our own. It carries its own ice radar called RIME, and here it is worth being honest about reach. RIME can sound to roughly 9 kilometers down. Ganymede's ice is thought to be many times deeper than that. So the radar will read the shallow layers, the top of the lid rather than the water beneath it, and the ocean there will still be inferred rather than seen. The third machine is not built for ice at all. Titan's air is about 4 times denser than the air you are breathing now, and its gravity is around 1/7 of Earth's, which together make it the easiest place in the solar system to fly. So the machine going there has 8 rotors, and it hops. Dragonfly is a rotorcraft roughly the size of a small car, warmed and powered by the heat of decaying plutonium. It will land, sit, work through the long Titan night, and then lift again, moving perhaps 8 kilometers at a time. Launch is set no earlier than July of 2028, and arrival is expected in 2034. It will work near a crater called Selk, chosen because an impact there once melted water ice and stirred it into the organic material lying about. Its instruments are there to read chemistry. What the dark grains are made of, what lies a little way beneath them, how the weather moves across the dunes. Like the others, it is not looking for life. It is looking at how far ordinary chemistry gets on its own. Set the arrival dates side by side and the shape of this work appears. 2030, then 2031, then 2034, with years of patient flying after each. Many of the people who built these machines will be well into another part of their lives by the time the data comes home, and they built them knowing that is normal in this field, and it is accepted without much complaint. There is something restful in a science that works on those timescales. Nothing is resolved this evening, and nothing needs to be. The radar has not yet been switched on above the ice. The rotors have not yet turned in that orange air, and the questions are all still open, sitting exactly where they were left. No promise is attached to any of it either. Reason may find a shell 3 kilometers thick, or 30, or something stranger than either, layered in ways nobody has thought to model. Dragonfly may land and find chemistry that stops well short of anything anyone hoped for. These instruments were built to measure rather than to confirm, and a measurement that disappoints is still a measurement. What is certain is only this. Somewhere out beyond the asteroids, in the dark, 3 small assemblies of metal and glass are moving steadily along paths worked out years ago, carrying their careful questions toward the ice. Each will arrive in its own year, quietly, long after tonight. Nobody watching needs to stay awake for it. Nobody has ever stood on any of these worlds, and nothing in what follows is a measurement. It is a reverie assembled out of numbers that are real and arranged into a body that is not there. Take it as invention gently made and let it go whenever you like. Begin on Titan at noon on level ground a little inland from the northern seas. The light would be orange and low and thick, the color of a lamp burning behind a curtain. Saturn lies a long way from the sun, and above you would hang a haze hundreds of kilometers deep, so noon on Titan is thought to be no brighter than deep dusk at home. You would not need to shade your eyes. There would be almost no shadow at your feet, only a soft darkening where you stood, because that haze scatters the light and delivers it from every direction at once. The air would rest on you a little more heavily than the air here does, and it would be thick, while your own weight dropped to something like a seventh of what it is now. People who design flying machines regard that combination as the kindest in the whole solar system. In such a place, a pair of broad wings would carry you in a slow circle with very little effort, and you would come down like a leaf. The sea ahead of you would not be water. It would be methane and ethane, kept liquid by a cold of around minus 180 degrees, and it would look almost black beneath that orange sky. Radar and reflected light both suggest those surfaces are extraordinarily flat, so any waves would be low and unhurried, more a slow breathing of the whole bay than anything that breaks. A dropped pebble of water ice would fall to the shoreline more slowly than it does here, and land with a dull knock, and lie there rounded and smooth. And you would hear that knock, because Titan has air, and air carries sound. Now let the ground change under you, and stand on Europa instead, where everything reverses. There is no air worth the name, so nothing outside your own body would make a noise you could hear. The quiet would not be the hush of a still night, which is always full of small sounds. It would be total, and it would be unbroken, and it is probably the hardest thing on this list to picture honestly. The ice underfoot would not be a floor of clear glass. The most recent readings of the shell hint at cracks and pores reaching hundreds of meters down, with a grain finer than a fingertip. So the top of Europa may be crumbly rather than solid, giving a little under a boot like old snow over gravel. It would be brilliantly bright. Europa returns several times as much sunlight as our own moon does. Even with the sun small and hard and 25 times fainter than it is here, the ground would glare and the sky above it would stay black. And Jupiter would be there. From the hemisphere that faces the planet, it would fill a great arc of the sky and never move from its place, because Europa keeps one face turned inward forever. It would not rise and it would not set. It would only go through its phases slowly over the 3.5 days it takes Europa to travel once around. In that same span, the ground beneath you would rise and settle again by about 30 meters, far too slowly for anybody to feel it happening. Enceladus would be different again, and smaller in every way that matters to a visitor. It has the brightest face in the solar system, a white so complete that it throws away almost all the light falling on it and remains bitterly cold underneath. Your weight there would be almost nothing at all. A gentle step would carry you further than you meant to go and set you down a long moment later. Near the southern fractures, a fine snow would be falling around you, drifting rather than dropping, most of it material that had already been thrown up once and was on its way back down. None of this has been seen. Every detail I have given you comes from an instrument that measured something else, and from a model built to explain it, and the models disagree with one another more often than the tidy version admits. Nobody knows how a boot would truly behave on Europa. Nobody has felt Titan's air move, or watched that orange light change through an afternoon, or stood anywhere at all with an ocean under their feet and no way to reach it. What we do have is stranger than a visit, in its way. We have a set of worlds described entirely from a distance by radio and radar, and the faint tug of gravity on a passing spacecraft, and the descriptions are detailed enough to walk through in the mind before sleep. The shore is dark and the sea is calm and the sky is a color no shore here has ever been, and none of it needs anybody there to go on being itself. It is simply going on as it has been going on for a very long time, and it will keep going on tonight while you rest. The room you are lying in has a temperature of its own, and a faint sound and a darkness behind your eyelids that belongs to no other room. There is water in the pipes inside the walls. There is water in the air outside, whether or not any rain is falling tonight. And most of what is resting here under the blanket is water as well, held in soft compartments, moving slowly, kept warm from the inside rather than from above. That last idea is really the whole of what you have been hearing tonight. Warmth from within and not from the sky. Sunlight out at Jupiter is around 25 times fainter than the light that reaches your window, and further out it is fainter still. None of the water in those places is liquid because of the sun. It stays liquid for other reasons, and they differ from moon to moon. In one or two of them, a large planet pulls at the ice and the rock, while neighboring moons keep the orbit from settling into a perfect circle. Elsewhere, the rock itself decays slowly and gives off a little warmth of its own. Salts and other compounds lower the temperature at which water will freeze. And a shell of ice holds heat in much the way a blanket does. Ice is the most ordinary material in this story. You have held it in a glass and watched it float, which it does because water is peculiar when it freezes and takes up more room. Deep inside a large moon, under enough pressure, the crystal packs itself more tightly instead until it becomes denser than the water it came from. Then it falls rather than floats. The same familiar material, behaving in the opposite way, decided only by the weight above it. If 2 or 3 things stay with you from tonight, let them be the small ones. There is a ridge on the ice of northwest Greenland, 2 low lines with a shallow trough running between them. Allowing for the difference in gravity, it has the same shape as the commonest feature on the face of Europa. On Greenland, the cause is known to be a pocket of water trapped inside the ice, freezing and pressing outward until the surface above it lifted. At the south pole of Enceladus, there are 4 long fractures, each roughly 130 kilometers from end to end, and they are warmer than the frozen ground around them. Out of them rises a tall curtain of ice grains and vapor. Most of it falls back as snow. A little escapes for good, and that little is what builds the faint outer ring of Saturn. On a dry floodplain on Titan, there are rounded stones of water ice, 5 to 15 centimeters across, resting on darker ground damp with methane. They were tumbled smooth by a liquid that was never water. A camera looked at them for a little while and then went quiet, and they are still lying there in the orange light. And Europa itself rises and falls by something like 30 meters once in every 3.5 days, the whole moon breathing at about the height of a 10-story building. Beneath the ice of West Antarctica, 800 meters down, there is a shallow lake with living things in it that have never had light and do not need it. They make their living from iron and sulfur and nitrogen compounds. It was found by people standing out in the wind, melting a narrow, clean hole and lowering a bottle into the dark. Nobody has ever seen any of these oceans. Every one of them is an inference, drawn from a tiny wobble, a ripple in a magnetic field, a crack shaped a certain way. There is thought to be more liquid water out there than in every sea on this planet, and all of it is known only by the marks it leaves on the outside. There is a spacecraft crossing the gap between here and Jupiter tonight, its electronics folded into a metal box to keep the radiation out. Someone fixed a plate to that box carrying a poem and the recorded shapes of human voices saying the word water in more than 100 spoken languages. It was made for the people who sent it, really. It was still worth doing. Those oceans asked nothing of anybody. They were dark and calm long before anyone here thought to wonder about them, and they are dark and calm now. Machines are on their way, and they will take years yet to arrive, and what they bring back will be thickness and salt and chemistry rather than an answer to the largest question. The water will carry on either way. It turns in slow circulations nobody has ever drawn, under a ceiling nobody has ever been beneath. You are mostly water yourself, and the water in you is also moving in the dark. Blood in the small vessels, the fluid in your eye, the thin warm film across your tongue. It is kept warm from the inside, as theirs is. You do not have to think about any of it for it to carry on. There is nothing to decide tonight. There is nothing left to understand. The ice is holding far out in the cold. The water beneath it is calm and dark. It has been calm for a very long time. Let your breathing slow to meet it. Let the room go quiet around you. Let the moons keep turning without you. Sleep well and rest easily now. The dark water is still there. Good night, and sleep deeply now.